The Indian Association of Structural Engineers, also known as IAStructE, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IAStructE is registered under the Societies Registration Act 21 of 1860. IAStructE is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IAStructE has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar. As its president, IAStructE is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IAStructE has collaboration with various international professional like-minded associations and institutions. IAStructE's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IAStructE endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IAStructE is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs, seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements, and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IAStructE's activities are widely appreciated and known for quality technical contents. IAStructE is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IAStructE's publications are becoming popular with time. IAStructE has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IAStructE started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IAStructE is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IAStructE has its student chapters in several leading engineering institutions as well. Membership of IAStructE is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IAStructE is available on its website www.iastructe.co.in.
Good. So, welcome to this particular webinar on a very interesting topic, that is when hard hats meet soft tools. by my young friend Prateek Jain. And this particular webinar is being organized by Western region of IAStructE. Along with me, Mr. Sandeep Pattiwar is also present. And I believe most of you know Pratik, but still, as a formality, I will give a short introduction of him. Basically, Pratik has done his dual degree from IIT Bombay, I think in 2010.
Yes, sir.
And after that, he has joined Gammon. There he was working with the Surat cable stay bridge and few natural draft cooling towers
Yes.
for about 2.5 years. And then 2013, along with his classmates and colleagues in Gammon, he founded a Force Structural Engineers Private Limited, and doing extremely interesting projects. So, being a very passionate in structural engineering and bridge engineering, and basically working on a very interesting ideas, concepts. That is quite interesting. So when I saw the topic, I was very quite curious, and then when yesterday this IAStructE asked me to be a coordinator, but yeah, why not? So welcome all of you, and welcome Sandeep also. So I request Sandeep, you want to say something, or
Yeah, I just as Umesh Rasharke has said, this webinar is initiated by the Western region of IAStructE, and I want to give a special thanks to Shri Rashirke sir, who is very eminent. Actually, he himself has praised about Prateek Jain, so and he has agreed to be the moderator of this webinar. So that's why, and I think recently, his company also has completed one kind of unique structure, signature, iconic structure, I will say, crossing the Santa Cruz road. So that is a very brief introduction I will say about, and very humble that he is humbly agreed. So let us forward back to Rashirke.
so Pratik, ah,
Sir.
eager to listen to you, whatever the news.
Okay.
Saying.
Thank you, sir. First of all, thank you, IAStructE. Thank you, both of you, for hosting me here. And thank you, everyone, for being there. I know it's mostly a one-way communication here, so all of you are listening. And I hope this presentation, which I'm going to give you, adds, bring value to your professional life. And there are certain ideas which we are quite passionate about. So, through this medium, I'll be able to share with you. So, sir, if you allow me, I'll shift to the presentation here and quickly begin with the talk. Okay. Yes, so I'll be sharing the screen. I just need a confirmation from you if you are able to see it.
Yeah, it is
Okay.
visible. Yes.
Okay. So I'll start with the topic first. I think it is a quirky topic when it says hard hats meet soft tools. So I was thinking about, I wanted to share my experience with the tools that we have created, and I was wondering what could be, a catchy title. So I came across this. It's basically, the idea is that we are all engineers here. We are designing bridges, buildings, and different kinds of structures. And I think in the modern era of technology, we have got so many tools which we can utilize to our advantage, saving time, bringing accuracy, increasing the quality. So I thought, why not share our experience in the last 12 years working with different kinds of tools. So I'll quickly begin with the
with a very brief introduction about our firm. So we were established in 2013, as Umesh sir mentioned, that we graduated in 2010, and after only 3 years of work experience, we started our firm. We did have a lot of doubts about it, but we are, with God's grace, we are fortunate enough to have reached to this to this place. So we have 4 partners together. We are all batchmates. Right now, we have only one office, which is in Navi Mumbai. And currently, our team strength is 80 people with a good mix of engineering, drafting, and support staff. And we are working mainly in the transportation infrastructure with design of roads and bridges. And so far, I mean, symbolically, we have done more than 400 plus bridges, including, the small culverts and moving on to large cable stayed bridges. And we have a very high attraction for special bridges. We are always on the lookout for the long span ones like cable stayed, extra doors, arches, and that's our main attraction. And we are generally approaching our business very systematically. And recently, we have also been awarded as 9001 certified ISO certificate. Now, just a glimpse of what we have done so far. These are some of the pictures of our most prestigious projects. On the top two, you see the Samriddhi Mahamarg from Mumbai to Nagpur, and in the center screen, you see Zuari approaches, which we did long back with one of the first spine and wing type structures with a deck width of 28 meters, and so it was done in 3 pieces. Center piece was 9 meter, and then there were around 9 meters each piece on the right and left. On the left mid, you see a network arch in blue color, which I'm going to share the launching of this as well with you. It was one of our, I would say, most proud moment recently, that we have been able to set a world record probably, which I'll be sharing very soon. And some other projects like UHP FRC flyovers, one of the world's longest flyover in Nagpur. We are the designers for that. And an extra dose bridge in Jabalpur, which is going to be opened tomorrow. I am not there in the opening ceremony because I had webinar to give. Yes, so I'll speak briefly about myself. So I'm one of the 4 founders at Force SE, and I am generally responsible for getting the work. Like, as a business owner, we are also, I mean, apart from designing and drawings, we also have to, manage the work. We also have to get money, to keep the show running. And in addition to money, I'm also responsible for hiring or getting good people to become a part of our family, become a part of our team, and grow with us. And basically everything else that my partners don't want to do, so it ends up at me. So I'm mostly doing the non-technical stuff sometimes. A key very important responsibility that I have in my organization is to build in-house tools, which we'll be talking about in this in the next 30 minutes. And I personally love teaching, and I mean, that's the reason why I'm here. I want to share my knowledge with the younger generation, and maybe in the longer run, I also have a dream to build a school for bridge engineering. And maybe after I graduate from my own organization, sometimes I would like to create a school for bridge engineering. Now, yes, so moving on to the stock, I just want to set the objective very clear that I want to incept ideas among the younger engineering, budding engineers, that, in this era of technology, we have so much to do. We can create so much. And I think it's just that through our experiences, I would like to incept this idea among people that, yes, through various softwares and tools available in the market right now, we can combine them together and create something very, very wonderful. So my presentation will be generally structured as a collection of past experience, what we have done, and some of our ongoing experiments, which are also very exciting for us. And I'll be sharing towards the end of the presentation, like what we are trying to do. And if we are successful, that could be something like a game changer. And some of the possibilities of the future, which we want to go in that direction. And but yes, again, an idea which will be appreciated by all of you. And if the time permits, maybe in the Q&A we can also talk about some of the advantages and risks of going too much into technology or using too much of software. So moving on, I'll be breaking my presentation with software wise, because we are using multiple ones. So like, first I'll start with Sophistic. This is the backbone of our business. I mean, most of our analysis happens in this. So being a design engineering firm, analysis is a very big part of what we do on a day-to-day basis. So this forms the basis of that. And we have been using this software for last 15 years now, I would say, because I started my career with this and we were introduced to this, and that's how we continue to build on this software. One thing which we really like about this is it's a module-based software. So when you have in the part of analysis, there are different stages. You have a stage of modeling the geometry. You have stages when you have to define the materials. You have loadings. Then you have pre-stressing definitions, you have construction stages. So in this software, you are able to do different tasks in different modules. And the network licensing is also very powerful here because at this point of time, when we have got around 40 engineers, we are only using 3 licenses. And those 3 licenses are very efficiently used because each module takes a certain amount of time. And then once the module is run, the license is free to be used by another person. So it's very efficient usage, and being a module based makes it even more powerful. Now, it has got axis-based modeling. It's a boon for bridges because, I mean, those who are bridge engineers here know that hardly we come across bridges which are absolutely straight. We have got curvatures, we've got super elevations. So axis-based modeling, where you have a curved plan and profile, it becomes very important that your software is able to understand those curvatures. The thing that we cherish about this particular tool is that it has got a very powerful text editor, something like C++ and VBA. Most of you might have seen, and this enables us to program the standard structures. Like I'll be showing you some typical structures like box type culverts or eye girders, which are very high in numbers, but they are relatively similar in nature, so you can program them. But it also has got a powerful CAD based GUI. So when you have got a very unique problem which cannot be programmed, or it is something which you won't come across next time, so you can use the CAD based GUI. So I mean, here we are able to make use of our drafting technicians because they can make the model in CAD and they simply gets transported to the software for analysis. And they have a feature where you integrate everything. So whether you're writing in text, whether you're doing in CAD, it all comes together, and this SSD integrates somehow. It has got capable of advanced analysis, which we have been able to leverage, like non-linearities of materials and geometry, construction stages, because the long span bridges or the complicated ones require construction stages to be modeled very, very accurately for geometry, for stresses during construction, which gets logged. Then you have cable sag, stay cable optimization. So a lot of advanced features nowadays we need for those complex bridges. Now, from here, I just want to share a video that we created for the launching of the 100-meter network arch bridge in Mizoram. I will be playing it. There can be a bit of lag while the video is playing and I am speaking, so please bear with me. I'll try to be, be a bit slow and go along with the video. So the bridge is located in Mizoram, and it's in a pretty remote area, but it is connecting the main city of Aizawl to the airport. The entire permanent design as well as the enabling structures or the launching scheme was done by us. What you see on the screen is that the arch is placed behind the abutment and it is ready for launch. The analysis were done using Sophistic, and we have been able to use very high-end buckling analysis for this particular permanent design and also for the temporary construction. So right now on the screen, what you see is that the bridge has been moved from abutment A2. The bridge is around 450 tons, and it is moved from A2 to A1 with the help of ropes and towers. Right now, it is in the middle where 225 tons of point load is sitting on the system of cables. And you have got towers on the right and left. The right tower is slightly higher as compared to the left tower because we wanted the gravity to assist the movement of the bridge and not push or pull it. So this was completed in around 6 hours. So I mean, the bridge moved on these ropes, and all of the equipments that you're seeing are all done by the contractor and the fabricator themselves. There's no, external or imported items involved in this. And on the screen, who you see the this is a particular case when a designer launched the bridge. I mean, my partner who was responsible for the design was also responsible for launching, because he was constantly controlling the winches that were moving the bridge. So why I showed this is because we were able to leverage the capabilities of the software to go into advanced buckling analysis, and therefore the structure was very light. It was it is designed in the slender regime. But you see on the arches and ties were pretty slender. So we were able to make use of that capability to arrive at a much economic structure. Now, coming to our typical style is that whenever we get a project, whether it is a long river bridge or an elevated corridor within a city, you always start with the initial setup of the project. So first you finalize what kind of a superstructure system will be used, what will be the aesthetic shape of the caps and size, or rather the shape of the substructures like pier, whether you want to go circular or rectangular. So first you set that up. So basically like forming a design basis for that project. Now, once you have identified those fixed parameters, then we move on to a particular Excel sheet. That Excel sheet is capable of handling all the variable parameters of a structure. So suppose like when we are dealing with a box builder superstructure, so we have already set up the cross section, but the radius, the length of the span is likely to vary along different pier positions. So we are able to set those parameters here. Now, these parameters, once we have set in the Excel sheet, we are able to transfer them to something what we have already programmed. So, as I mentioned you that we have got a text editor like C++ and VBA. We have created scripts. Those scripts take the parameters from the Excel. Now we paste the script to the text editor of Sophistic. We do the complete analysis, and we extract the result from the software to Excel for post-processing. Now, why we go back to Excel is because the codal checks, specifically the IRC codes, are sometimes not very well covered in these international software. So I feel that it's always best to bring those numbers like bending, the fundamental numbers like bending moment, shear forces, you bring them back to Excel, and then you have all the power to post process whatever shear checks you want to show, like a typical shear check as per IRC 112 or some stress checks. You can do all in your Excel, so that it becomes more readable, it becomes more understandable by the one who is checking it. Now, it has got ability that your Excels can be connected to the software, so you really don't need to manually paste the data. The Excel is able to read so whenever an analysis runs, the numbers are updated within the database of the software. So all your forces, deflections, everything is updated, and Excel is able to pull the data behind the scene. You don't have to, like manually copy and paste it. And even the graphical outputs, like, so we strongly believe that a good design report contains a lot of visual information, like all of your forces and bending on diagrams, everything should be shown in a visual manner instead of a tabular format. So we have always used more images, but then images, how do we whenever an analysis changes, how do we update that? So fortunately, we also have an ability that around 60 to 70 images in one particular design file, we are able to export from Sophistic, and Excel is able to read all the updated images and shows it in the Excel. So I'll quickly move on to the next video, which will give you an idea of how we do it. So we do it multiple times. As you see that, design is never done in the first time. We have to run multiple iterations. Sometimes we have to change the pre-stressing, change the reinforcement. So all of this iterations you do multiple times, and it is very fast because the entire system runs through, like there is very less manual intervention. And once you have reached to the most optimized design, as a designer, you feel that, okay, I have reached to the best possible design, you simply print that Excel as your design report. So here is a small video which is about a post-tension eye girder. Again, a very standard structures. Comes in variety, can be from deck width 12 meter to 21 meters, can span from 20 meters to 35, 37, 38 meters. So here we have created a similar Excel. From that Excel, we are able to paste the data back to Teddy. And here you can see that the analysis runs and you have a three girder system on the screen. And then the analysis, everything is run. Now we are extracting the output. So all the images which we mentioned, that we have got this in folder, and this is exported and this goes back to your Excel. Now the result extraction also happens from the Excel. So you have got all the numbers also for the post-processing automatically, and you've got the images also from Sophistic. Now, so this was one iteration where we did a three girder system. Now, suppose if we want to change it to a much wider superstructure. So here we have a 38 meter span, which 21.25 like an expressway deck width. We go again. So this is the actual rate at which the work is done. So what you're seeing right now is a real-time video. So you go, you again simply change it, and you have a completely new system where you're now ready. You have carried out the analysis, and now you do the same process once again. And I'll just let you watch the video. So again, the 70 pictures are exported and goes into it is also updated in the Excel file. Now the results are extracted. And here you have on the screen a 6 girder system. The report is ready. You can simply print it and go ahead. So the design earlier, when maybe like when Umesh sir or Sandeep sir would have been designing the structures maybe 20 years back, they would have to do everything on a manual basis, right? They would have to go to the software, do it once again, completely change the geometry. But with the modern tools, you can see that what's the power that they have offered to us. Like in a matter of minutes, we are able to completely change the model, do the analysis, and get the results in a presentable format. So you're able to design much, much faster as compared to what our seniors would have done maybe 10 years or 15 years ago. So again, another video, there'll be a series of video, which just because I wanted to share our experience to give you ideas on what we can create. So this is another video where we have tried to simulate the substructure analysis, because you get a variety of substructures. Sometimes you have a single pier with concentric pier cap. Sometimes you have an eccentric pier. You also have portal piers with the number of bearings changing. So we have tried to incorporate all those parameters here. And the same philosophy again applies that a VBA writes the file, and we are able to paste everything. Analysis is run. And what you see on the screen is a simple single pier with 6 piles along with the soil springs. And now with the same system, if we want to go for a more complicated, so if you want to go for like, a asymmetric portal where you have 2 piers and your cantilevers are also varied and your shape of the pier is also changed to circular, you have got more number of bearings instead of a box girder, maybe a couple of bearings. You move to eye girder where you got maybe 6, 8, 10 bearings. So again, you go back to the same. Again, it is done in the real time. You go for the analysis, and what you have now on the screen is a completely different system, which is a portal with an inverted T section and 4 piles under each column. So this gives us the power to simulate the substructures much faster. So now once we have this, we can go for further obviously additions as the project demands. If you want to add some additional loads, you can always do that, but this will always function as the basic geometry and load creation module. So this was for the substructure. And yeah, so these are the different kinds of structures that we have designed using this tool, which also includes the standard ones where we have gone for programming and automation. But there are also a lot of non-standard ones like extra dosed or the network arches or Zuari spine and wing, which were completely unique in all terms. And there we have gone for a much straightforward approach, conventional approach. But even in that case, once you have simulated, there is always a potential for automation, because when you're designing, it's not always a one-time thing. You will be optimizing it, you'll be changing the thicknesses, you'll be changing the reinforcement. So it's always a good idea to set up a basic automation to and from your design tools. Now, moving on to another new software that we are exploring is IdeaStatica, which is very good for steel connection design. We were not aware before the Mizoram project that we did. And it has got brilliant capabilities of doing steel connections, because it has got inbuilt elements where you can simply tell that, okay, this is an orthogonal connection, this is a plate-to-plate connection. You can have gussets, bolts, everything is defined as a custom item. So you are able to model very quickly, and it is also good for, we are also exploring it for the concrete elements where you have got D zones, which you cannot simply use the bending theory or the simpler theory. So you have to go for strut and tie models at certain places. So it is also good for that. So this is a snapshot of one of the connections in Mizoram that we have done. Now, the idea of using the software originated from the fact that steel connections are fairly complicated. Like you can see on the screen that one particular element gets connected to three other elements. So the nature of forces is also like you have got bending moments, you've got axial forces, shear forces, and it is all coming from three different directions. So now you can imagine that the connection itself is not a simple problem. It is fairly complicated, and when we do not use such tools, we end up doing something very simplified, and the simplification might not just end up in a conservative design, but at times it also may happen that we may underestimate some phenomena. Like in this particular case, certain stiffeners were required because there was, when there was bending in the node, it was yielding the main section. So to avoid the yielding of the main section, we went for the stiffener. Now, also, a beautiful method to design connection is that basically you start with just the main members and you apply the required forces. Now, once you apply, you see that there are certain failing points. Once you can see that, okay, these are the points which are failing and failing under which kind of a load, you are able to counteract the failure by introducing maybe a stiffener or something else which basically counteracts the failure. Now you keep on adding those items, and in the end you reach to a very effective connection because you have seen the failure patterns first, and once you have understood the failures, you have gradually one by one attacked each failure and made sure that there is that the stresses within different steel elements remain within control. So that's how you reach to a very efficient and a very, I would say, intuitive connection design. So that was IdeaStatica. Again, there was no programming so far, but it was used as a very advanced tool for connection design. Coming to Midas NX, we also use this because it's also a wonderful software for advanced analysis. The capabilities are comparable to Sophistic, including the construction stages or the post-tensioning, long-term losses. Everything is also covered in this. And recently, we have come to know that the newer version of Midas also has a possibility of automation using additional tool called Grasshopper. I'll be talking about it a bit more. So you can code similar to like in Sophistic, you are now able to code in Midas NX with the help of Grasshopper. And this is widely, I have seen that Midas is widely accepted across the globe. So we have come across a problem in Middle East where they were very clear that we are only going to accept our all the analysis in Midas and no other software. So we were thinking that, okay, now we have to do the problem in the same fashion that we do with our with Sophistic, and now this time with Midas. So similar to that, like we have the problem of something as an interchange. So you've got curved spans, because in interchange you have elevated interchange, you have curves, you have got variable heights of the pier. So something like this. So on the right hand side, what you see is a Grasshopper screen, It's a visual coding program. It's very similar to Teddy, I would say, a text editor, but it is much more intuitive because you are able to see, the flow of information. You have switches, and you can, you can code different parts of geometry creation or loads in different parts. And what Midas has done is Midas has created an add-in for Grasshopper, so you can directly use the commands that are used in Midas, and you can simply call them in Grasshopper. So Grasshopper in general is a much much global or a much generic visual programming tool, but Midas has already built a layer on it, and using that layer, we are able to simulate or program the functions of Midas. So like on the screen, what you see earlier, we modeled a twin cell box. Now we are changing it to a different span configuration. We updated it, so we also wanted to change the the cross section from a 2 cell box to maybe a 3 cell box, introduce a curvature. So again, just simply in changing the inputs, we are able to completely modify the cross section. We are able to modify the alignment, and from the Grasshopper itself, you are able to run the loading, whether it is live loading, dead loading, and you reach to this stage. So even this is very powerful. If you're using Midas, then Grasshopper assistance can help you to automate your standardized problems there. Now, coming to our favorite STAAD.Pro, I think all of us have used STAAD.Pro. I mean, the beginning of the career always happens with this very simple yet very powerful tool. And I mean, I feel that this tool can never be replaced because it's very good for your simpler problems where you don't really have to go into construction stages or something. So you can do that. We extensively use this for our pre-bid stage because, as you know, that usually in pre-bid stage, we do not have more than 7 to 10 days of time to analyze or do a prelim engineering of the project and then finally arrive at the quantity. So we go with STAAD for that. And there is no, I mean, as far as I know, there is no direct programming in STAAD, but through .std files, that is the base text file of your STAAD.Pro, you're able to program that also. And OpenSTAAD allows you to integrate with Excel directly. So like how we saw in case of Sophistic that they are able to communicate Excel and Sophistic. In this case also, you are able to do that. This is a simple tool that we have created for cable state bridge geometry creation and live loading application. So as you're aware that cable stays are generally deterministic when they're being built using balance cantilever method. But once they're connected, once they're on the bearing, they become very indeterminate. And that's why for the live load analysis, you certainly need a software to come into play. So this is a very simple tool that can handle asymmetric, symmetric cable stays with different span lengths, pylon heights, cable numbers. You can change all of this. Again, go simply copy the code, update the STD file. And once you run it, now you have a asymmetric cable state bridge on the screen. And once we have the geometry ready, we do the analysis. So the live loading is also applied based on the function of the length of the bridge. So right now you'll be seeing on the screen that the live loading is also moved in steps, and the envelopes are then used for the pre-tender engineering of the cable state bridge. Yes, now here was all about this drawing, is rather analysis and design. We spoke a lot about how to analyze, but I think the real game lies in the drawing part, because the drawings are true language for a designer. Whatever we are envisioning, whatever we are creating in our head as a structure, gets communicated and built on site only through the means of drawing. So I think drawings are the language for a designer. So by default, I think in the current era, drawing means AutoCAD, or rather, CAD, like how the technicians draw it on in the 2 dimensions using lines and annotates them. So even for AutoCAD LT, there is a possibility to script. It's a brute force method, I would say, but we're still able to create some automations for some very repetitive structures using command line. So we use Excel, and in Excel again a parametric approach, and a VBA creates the inputs for this. So a lot of repetitive tasks, something like a box culvert, which I'll be showing you next, can be automated through this approach. So this helps us to save time for the drafting team because it's a repetitive task. Even they get bored of doing that. And very important is the engineers checking time, because engineers times are more valuable, very valuable. And repeat checking the same thing again and again can also lead to errors, which, first of all, we are saving time, and then you are also able to save the chances of error, because now the computer is able to create the drawing, so that probably wouldn't make mistake of that order. So here is a very simple tool, a very revolutionary tool, I would say, is to create the drawings of a box culvert. So this is just a face sheet where you fill the inputs. It has almost all the information which is required to build a box culvert drawing. Now, from here, we have created an entire script for AutoCAD. So what you see on the drawing, on the screen, is a drawing which is created completely by an Excel file. And it is done in not more than 10 seconds. Like the code runs in 10 seconds and you have the entire drawing with you, with the levels, with the information of all the nodes and all the sections that you see on this. Now, using this, actually, we were fortunate that we are doing a project in Middle East where we have to design and draw so many culverts. So, like so around 200 culverts are there. So now we have to design all of those culverts. So we thought, I mean, why to even design that? So we have brought it to the next level. And what you have on the screen is like another layer of programming. That what we have done is, this is the Excel sheet that does the complete designing of that culvert. And we have created a database that, okay, we have to design 50 types of culvert, so 50 groups of culvert. And so, like, the dimensions, the inner dimensions and the fill, you run this. So there is a piece of code that we've written. What it does is it runs all those 50 group designs. So what you see on the screen, it is run through the MS-DOS or the command prompt of the window, and it is copying the data from the Excel file, opening Sophistic, running all the Sophistic analysis, bringing all the data back to Excel, and then it is also creating the drawing based on the tool that we have created earlier. So if you have got n number of culverts, you can simply just define the parameters for those culverts in one Excel sheet, and this will help you to do that repetitive task, or maybe 50 to 100 times, whatever is required, by on its own. And it will create your design reports, it will create your analysis files, and it will also create the drawing. So this is something which, I mean, that was a next level that we have recently created, so I thought I'll share with you. Now, another in CAD, like this is a very, I think, a problem that most of the senior engineers face when they design balance cantilever bridges. So, the site requests cable coordinates to be given at every section, or maybe, at very high frequency. So again, this is a tool that we have created simply to assist the CLC design, that you have Excel, you have all the cable coordinates in the Excel. So when you transfer that, I mean, this thing has to be done by the draftsman. And if you have to create maybe 30, 40, 50 sections, it is a very manual labor to do that. And the cable coordinates also change quite frequently. So instead of, going to drafting team to create this, rather we used Excel to create something like this. So whenever there is a change of the cable profile, all you need to do is change your Excel sheet and run this VBA script once again. It will completely update your cable profile and cable coordinates in the form of table, and you can simply create a drawing out of it. Yes. Now, something very unique, I mean, not related to design or drawing, is something which we felt as a major pain point, was that our documents which are going out of the organizations were looking different. So what was the reason? Because every engineer has their own style of formatting the document. So what we thought is, rather, it doesn't look right. We should all have a single type of draw and designs originating from one office. So we created an add-in in Excel, which is just to do this, not so interesting part of documentation, which is adding table of contents, which is adding headers and footers, name of the document, revision. And this add-in is created, this add-in is installed in all the PCs. So while we are creating the document, all we need to do is once we want to publish the document, we run a series of commands using this add-in, and it will help us to format the document, all the margins, colors, and the document title. Everything is all taken from the Excel itself, and the document is printed, and now we have almost all the documents going out in exactly the same format, and there's no variation. Yes, this is also a very interesting tool, which I think will spark ideas in a lot of young people, or rather, I would say, who are doing a lot of tender work. So we created this as a optimization tool for a very simple problem, which is rectangular section, and for flexure only. So like your deck slab, when you design, it's a rectangular section problem with most of the time only flexure. Like your PSC box girder, if you have single cell or double cell box girder, that also is a pure flexure rectangular section. Your retaining walls are also flexure rectangular. So we come across this problem quite frequently in our engineering, bridge design. So we thought, why, let's build something which gives us an optimum solution. So here we select the grade of the concrete, we select the grade of the steel. So we have what we have done is we have done numerous, I would say thousands of iterations, and I mean done through computer simulation obviously, and we have created a database from where for different grades of material, from different cost of material, and for different bending moments, we simply have a big database from which it just goes and finds. So right now what you see is for a design ULS moment of 1000 and SLS moment of 700 and quasi moment of 400 with a crack width of 0.3. It has suggested you some cross sections, or rather depth of the section. So like a 600 depth with a main steel percentage of 0.8 will give you a utilization ratio of ULS as 96%, SLS as 86%, and quasi as 71%. And you can also see the running meter cost of the section. So from here you can actually take the starting point. So whenever you are going into a main design, you can always have a starting point using this tool. So when we are analyzing, we know the approximate bending moments. So we come here, which we see that what should be the optimum depth of the section, and we start from here. So yeah, this is again a very interesting tool that we made just something to use in the tender engineering. Yes, now this is a completely non-technical tool. It is a financial tool. As a business owner, I mean, I have the major headache of securing funds. So this is what you're seeing on the screen is basically a list of all the pending invoices from our clients. So what it does, I'll just pause it here a bit. So we are specifically selecting, the clients that we want to nudge for payments. And here we are first hand picking, okay, this one to nudge, this one, okay, not, maybe we have recently called them. So from this Excel sheet, once we have identified how many people to nudge, we press a button, and what it does, it sends email to all of them from different companies, from different projects, so they get a reminder for containing the details of the invoice information of when was it raised, what was the total amount, what was the due amount. So this also we kind of automated, because this helps us reach out to the customers more frequently, and helps us to secure more payment on time. So that was again what you saw just now of the financial tool. This I have created in less than 2 hours time. So, but with the help of ChatGPT. So coming to this, I mean, this is a wonderful tool at your disposal right now. It is an expert coder. So now you have so many tools you can see that has the capability to program. Even if you don't know how to program, if you just know the basics of it, all you need to do is go to ChatGPT or any other AI assistant for that matter, and give them the right prompts to create something which you want. So the earlier tool that you saw was done under 2 hours. So all I needed to know was basics of VBA, and I gave them the right prompt that I want to do this. This is my objective. This is how it should be working. So it can script in almost all languages. Now it is able to script in Teddy also, which is the Sophistic's native language. It can script in Python. It can script in any language that you want to use. So we use it for debugging also. So whenever we are writing a piece of code, suppose we are writing Sophistic. So what we'll do is, okay, I mean, if it's something is not right, we'll simply give the code to ChatGPT. It will understand that there is something wrong in the flow. It will give you a corrected version. And we also take help for commenting, because, commenting takes time. It's a good practice, which everybody should be doing in your codes. But when we are annotating, it takes a lot of time. So we ask ChatGPT to do the annotation. So it understands what line does what, and it helps you to add a small comment ahead of that. And a very interesting solution that we came with ChatGPT was your own GPT. So what we have done is we have created our own localized GPT. So the main chat GPT obviously has like a huge amount of data, but we don't want that. We want our own GPT to be trained only and only on IRC codes. So we took that GPT, we fed the IRC codes to it. So IRC 112, IRC 6, 22, 24, whatever IRC is relevant to you, you give that to that GPT to learn. And you do not allow any other, corruption. Like if there is a blog on the internet which also speaks about IRC, then the main chat GPT has that information also. But this one, which is a localized GPT, will have only the information about the code. So now we are using it as a search engine for the codes. So it has got the information about the relevant IRCs. We go there at the local GPT and we ask, suppose there is a question like, what is the clause about bridge deck drainage? So maybe I am not fully aware of where the drainage clause is written. Maybe it could be in IRC 42 or 58. I don't know the number. But because I've given all the IRC information, it goes into that. It lets me know that you're talking about bridge deck drainage, which can be found in these following codes at these clause number, and it will reiterate the clause for me. Now, GPTs can be delusional because, I mean, at the end, they are very good. They're extremely good, but there are certain points where they are delusional. They basically make mistakes, and they don't understand. So it's always a good idea to cross check. So once you have the information about the clause number and what the clause truly say, you simply go to that code, verify it yourself, and use it to your own wisdom. You basically do not trust 100% on the GPT, but use it as a tool. And it is also a great assistant for writing emails. I think it has helped me a lot whenever, if you have certain thoughts and you want to communicate something. So, I mean, writing an email would take a significant amount of time if you want to communicate very, very properly. You also want to, set the tone. Sometimes you need to be a little strict. Sometimes you need to be polite. So with this, you just need to put your thoughts, and you also need to set the tone, and it will give you a fairly good, I mean, around, I would say 90 to 95% of your work will be done. And only the remaining 5% is what you need to tweak on your email. So it makes email writing extremely fast. So makes efficient communication. So if you are communicating with a lot of people on email, I would suggest going for something like this. Now the experiment part. So far we spoke about the softwares that we have used, and to their limits. Like Sophistic, we have gone to an extreme ends. Now this is a new software, Tekla, or rather I would say the concept of BIM, which we are implementing right now. It's an experiment stage. We are learning, and with the belief that we would completely shift from modeling in AutoCAD LT, which is the current practice in industry, that you draw in 2D and then you print the drawings. But now we are trying to shift to 3D. So Tekla is a good software for 3D modeling, and which also has a capability to model the reinforcement bars. Now, the integration of Tekla with the other tools like Rhino and Grasshopper, which I mentioned above, further enhances the modeling capabilities, because Rhino being a pure 3D modeler, like the softwares like Blender or other 3D modelers, which are extremely powerful, which are very intuitive, Tekla can connect with them. So if you want to model extremely complicated geometries, you can model it in Rhino, push it to Tekla for your further usage. 2D drawings are generated from 3D model. Even though it is a redundant step, that once you have a 3D model, why do you want to make 2D drawings, right? The first question comes in is why don't we simply build using 3D models? But so far, yes, the practice is that we need to have 2D drawings for checking, for signing, for site to build that. But as we all agree that it is a very counterintuitive, because as engineers, we imagine everything in 3D. Our brain thinks in 3D. So we are thinking about a bridge in 3 dimension. Then we are converting everything into 2 dimension. We are asking the technician to draw in 2 dimension. Then so this is a process where there is a likely to cause errors or missing something. Those 2D drawings go to the site engineer, which also has to first read in 2D and create a 3D model in his head to build the bridge. So as you can see, that currently this, I mean, after the advancements in 3D modeling, this process seems to be quite inefficient and redundant now. So I feel the modern, the future is going to be a 3D, 3D models and building through 3D. So this results in 100% correct drawings. All the model, the 3D model, as well as the drawings are contained within one file. So you really don't have to deal with multiple CAD files located at different folders created by different people, because it's just one single source of truth. You are creating everything in one single file. And the best part is that if you have a change in the structure, you make the changes in the 3D model and the drawings get auto updated. So one example that I'm going to show you in the subsequent slide. So on the screen right now, what you have is a very simple problem that we thought we'll start with. It's one of the project that we are doing right now, which is currently being done in AutoCAD LT for for the mainstream. But at the same time, we are trying to deliver through a 3D approach also. So right now on the screen is a 3D model for that particular bridge substructure. This is the reinforcement that is modeled within the 3D. So the earlier one was only the geometry or the concrete dimensions. The second layer is the reinforcement that we have generated within the different elements. And here, as you can, I mean, this is the most powerful part of this workflow, is that right now you have a 3D model on the screen. I have opened the drawing section. So this is a drawing which is generated from the 3D model itself. So it's nothing is drawn by hand. It is all created by the computer looking at the 3D model. So as you can see, there are certain dimensions being marked. Now there is a change, for some reason we have to reduce the height of the cantilever tip. So we simply change the 3D model. The model is updated, and we have just opened the same drawing again, and you can see that the dimensions have changed. There is a revision bubble on it, which makes you understand that, okay, there was a change in this. And you can see that, okay, these were the areas that changed, because most of the places when you don't have a revision bubble, you don't know what has changed. So this is probably the most powerful part of this 3D to 2D, is that everything is dynamically connected. You change anything in the single source of truth, which is the 3D model. Everything gets reflected in whatever you have created in the background. So all the drawings, whether it is dimension, RC, levels, everything changes automatically. So we are currently in the process of, I mean, we are in the advanced stages, because we are able to create drawings through Tekla. And like now we want to go into the production also. Like these drawings go to the site for execution, and we strongly feel that AutoCAD or rather the 2D approach will be eliminated soon, and we will be building only and only in 3D. These 3D models are likely to go directly to the site. So I mean, right now on the screen is something which we are trying to do as a connection from Rhino, Grasshopper, and Tekla. So this is a little bit complex geometry. As you can see, it's a strutted box with variable web thicknesses, variable soffits, presence of discrete struts. So we are trying to model this in Rhino, which has a much higher capabilities in terms of geometry modeling. And this is also through Grasshopper. So Grasshopper gives you power to parameterize. So maybe, once you have coded everything, you can change the width of the box, you can change the depth of the box, because you have everything programmed. Now, as almost towards the final stages of the presentation, I want to communicate a very strong message to all of you, from the young ones to the most senior ones, is that we have done enough of 2D. Now let's shift to 3D. completely. There are clear merits to shifting to 3D, because then there will be paperless execution. Your site people can have tablets, or rather I have seen augmented reality also come into play, where just glasses will give you the power to see the structure actual on site. So this gives you much simpler execution abilities. You can see everything. You can probe into everything. If you have doubts, you can go into the 3D model and ask for information. This also enhances collaboration between the within the company as well as outside the company, because you're working on a single source of truth. Everybody is working on just one single information. It also allows for digital checking, because checking a 3D model is much simpler than checking 2D drawings, because 2D drawings, there are grammatical errors. There are sometimes some detail was changed, but the other one which was affected was not changed. So everything I will need to see. That's very inefficient. But now I can check in 3D. I can provide an approval in 3 dimension. The documentation is also online, because again, one file is containing all the information. You really don't need to keep maintain the drawings here. And like, we have this big problem that whenever we are working on some existing structure, and we ask for, okay, give us the as built drawings, so usually we don't get it, because nobody has a properly documented set of drawings or approved as built drawings. So it's always good to move to a digital system where you can access any set of drawings by means of your chainage, name of the bridge. You can simply access that, and it can be preserved for years. And like, it will integrate with the digital twin, so you have got multiple services coming after that. So like, we are applying sensors to the bridges nowadays to do the health monitoring. So this particular 3D model has all the information. It has reinforcement dimensions. Now you can have the sensor information also there. So one particular model is able to give you a complete picture of what your structure has, and what it is doing right now. And from this, this is my last slide, and this is about something which I really appreciate and which we need to do, because in our country we are building very fast. I think we all agree that the rate at which we are building our bridges or roads is extremely high than what we can probably digest or monitor. So I think technology really need to come into this, where we are able to monitor our assets or our bridges through through our desks. So this is a video from somebody else. So what you see on the screen is a digital twin of an actual bridge. The drones fly over the bridge, and with the help of high definition images and videos, using a technology called photogrammetry, we are able to stitch all of them together and create a real 3D model of the bridge. And what you see on the screen is the actual model, or rather the actual bridge converted into a digital format. And through this 4K images or videos, you are able to identify the defects that are coming in the structure during service. Like on your screen, what you have is like a spalling of the concrete cover. And so you can also see the bridge in your augmented reality within your office. Now, why this is important is because people like, very senior people like Umesh sir, Sandeep sir, Bhaumik sir, wouldn't go to a bridge site, maybe in Aizawl, and then, go underneath the bridge and look for the problems and then suggest some correction. It is very unlikely, because, it will always be best that the senior people or the most brilliant structural engineers get information about the bridge in this format, so that they can be on their desk and review the bridge with such high details, apply their observations. So suppose if I find some kind of a cracking, I would mark it. I would say, okay, this needs some attention. And then, somebody else also comes in and says, yeah, I agree with you. There needs to be some correction. So people can collaborate. More people can analyze or review that bridge. They can give their observations. Based on that, some rectification measures, if required, can be taken, and everything is recorded digitally. You do a survey today, and maybe after a year you do it again, or after a year you do it again. So you have the evolution of the problem as well, not just the problem at that point of time. And these technologies are all real. I mean, drones are real, photogrammetry is real. this can be created very easily, and I think there's a dire need for us to build such a system right now where governments should insist on monitoring the bridges through this fashion where they have actual access to the bridge without even going on to the bridge. So I'll just like to conclude here. I think I've taken quite a significant amount of time. So thank you, IAStructE, for giving me the opportunity, and to all the participants for patiently listening. And I'm open to discussions now if you have any queries.
So excellent, Prateek.
Thank you so much, sir. Thank you so much.
I have missed such a vast information you have covered in a very, very short and very effective manner.
Thank you, sir. I think I did not cross the time limit.
No.
Okay. Thank you, sir. Yes, sir.
Some few quick comments before I hand over to Sandeep, and we will take the question and answers. See,
Sure.
in last 20-25 years, the world has changed quite a lot.
Agreed, sir.
Okay, and it has become, there was a one book called The World is Flat. Thing. So whatever the technology is available in the developed countries, like Europe or Americas, the same technology, the software, the hardware, everything is now available on our fingertips.
Exactly,
So,
sir.
means the entire the technology you can use at the same level what other countries are using, especially the
Yes.
all these tools.
Yes, sir.
So that has made things really, that democratization of the technology is now happening very fast. Okay, so that is the one main comment. The second is whenever the generations changes, there is always a criticism by the old generation. When
Yes.
I used to work in a stoop, they used to tell me first do hand calculation, don't
Yes,
touch
sir.
computers. Okay.
Okay.
Then only you will get an insight into the structures. And I
Yes.
used to fight with my seniors.
Okay.
Doing that. In
Yes.
fact, the use of a computers, use of a whatever the analytical tools available at that time, used to
Yes.
have very primitive softwares like a
Yes, sir.
plane grid, and STAAD came quite a later. In fact, that helps in understanding the structure. Nothing like that you have to work by hand calculation.
Right,
Now
sir.
the things are moved quite far away.
Yes, sir.
So you develop that insight very fast using all these tools, like I
Yes.
said, Sophistic or Midas or whatever the tools you have shown. So that has become very, very you can say the advantage to the
Yes.
structural engineers. So nothing to worry. You straight away go and use the softwares. Of course, you will learn to the software itself. See, when you see the our time the deform shape, that gives a quite a good insight.
Agreed,
How
sir.
that if you see the first model shape, first
Yes, sir.
frequency, second frequency, you come to know how your structure is behaving.
Right.
So that is quite a good advancement
Yes.
the structural engineering. And other things are happening very fast and good that all of us are learning those changes and adopting those developments very fast. So great, proud of you
Thank
and
you so much, sir. Thank
and
you so much.
doing such wonderful things. So with that, I will switch over to Sandeep. And if any questions are there, please write down in
Yes.
the question and answer chat box.
Yes, sir.
If somebody wants to speak, we can open their uh,
I
connection.
think, yes, I would certainly love to have an interaction because I think that will make it more effective. So if we can have that.
I think your presentation and the name of the presentation, which is Hard Hats Meet Soft Tools, has
Yes.
already created so much curiosity. Everybody wanted
I
to,
guess,
I
sir.
think, know that what is the meaning of that. And I think after the presentation, everybody might have realized that what you mean to say. I
Okay,
think
thank you, sir.
many a times, either a structural engineer is a completely technical person, a technical engineer, and and the other person is actually software or
Yes,
that
sir.
kind of person who is very good in a software handling the machines and then tools and all those things.
Yes.
But what you have done the is integration of the both the ends here, so
Mhm.
that it is good for the see, first is the understanding of the structure, and second
Yes,
is the
sir.
good for the speed. So both
Yes.
the things are very important nowadays with the modern for the modern structure, where the new kind of structures are there, and then again the repetition. See,
Yes, sir.
as you have enumerated in a say box kind of structure, which is say maybe 200, 300, 400, and
Yes, sir.
where see it is a modern tool, it is expected that accuracy should be 100%. So if we have a actually so much effort is placed in a developing one program where it is converts all your kind of design into the drawings or accuracy or the design and all those things. It is very nice tool and nice reputation, and I think productivity and all those things will be also
Yes, sir.
increased. And in India,
Yes.
where the infrastructure requirement is really growing very fast, I think
Yes, sir.
I think many people in this forum maybe have actually waiting that how to actually do that. I think
Yes, sir.
some questions have been asked that we wanted to we wanted to have this software, but I think this is something someone has to create from your own ideas. You have given
Yes.
ideas to them,
Yes,
and
sir.
now it is they have their own responsibility, because this is all commercial software which you have integrated
Yes, sir.
with a best use.
Yes, sir.
It was a very nice presentation
Thank
listening.
you so much, sir. Thank you so much. And the objective was just to insert ideas. I think there are many, many ideas, and I
Yeah,
think there are wonderful engineers in the audience who can think much, much more than what we have created. And it was just to stir that, that ring that bell, so that people start creating this way. And as you rightly said, the importance of the fundamentals still remains, because softwares are only tools,
so
and they are always helping you to do faster, better, more accurate. But before that, first thing is you have to be able to understand the pending movements. You have
great.
to be you have to be intuitively understanding the behavior of the structure. Software help you to build that. So I think that's the only risk which I feel comes with designing or analyzing with software, that yes, if you don't be careful, if you're not careful with the fundamentals, you might end up in a wrong direction. But I think if you are aware that okay, fundamentals are far more important than, because these are just tools, and once I understand the fundamentals, there is no limit to how fast or how better can I do.
Yeah.
So, rightly
And
said on.
another thing, I like the way you have created in a very simple manner, so that any person who
Yes,
understand the technical language can feed the input and then create the
yes,
output. See,
yes,
otherwise, see most of the times what happen, you are making some tool, but that
Mhm.
tool is only can be used by that only one person who has prepared that tool.
Right,
But see,
right.
if it is a generalized tool,
Yes,
and it can be used by anyone who is
yes.
who is who has this access to your software.
Definitely, sir. I think we do take care, because at the end of the day, the productivity comes when more and more people are able to use the tool. So
Yeah,
it is very important that is user friendly, as well as proof of the mistake. I mean, because
correct.
there are likelihood of some mistakes happening, so we have to make sure that okay, that is also taken care in the program. That once the mistake is made, it is able to inform that something like this looks odd, and you should be able to look into that before you proceed.
I just wanted to understand
Yes, sir.
my curiosity. See,
Yes,
suppose
sir.
if you are doing some, kind of this kind of in interacting tool,
Yes, sir.
from connecting say Sophistic to the Excel and then VBA and then all
Yes,
those
sir.
things that how much typically takes time? Maybe if now, maybe 1 month, 2 month, 3 month, because you need to do so many things, maybe checking, then
Yes, sir.
debugging, then troubleshooting, and
Yes,
all
sir.
those things are behind you. See, it is now, right now, you are showing the software. It
Yes,
looks
sir.
like that it was so easy. It has done the job in a say
Yes,
15
sir.
minutes. But
Yes, sir.
before doing the job in a 15 minutes, you have a so much hard work you might have done it.
Definitely, sir. Definitely. In fact, the real effort goes into that making only, as you rightly said, debugging is a big part of it, because we have to run extreme cases sometimes that, you have to go for extremes, you have to go for many random iterations, and you have to make mistakes intentionally so that you are able to see those mistakes in somewhere in the outcome, so that you can know, okay, this is a mistake, we need to take care of this. So, I mean, I would like to add to this is we have got an automation team dedicated to this process. So we identify our problems on a day-to-day basis, like how you saw the formatting tool, right? That would probably an engineer would never spend the time on that, because he's able to somehow, spend maybe 15, 20, 30 minutes on formatting. But we saw that as a problem. I said, I mean, my automation team has to create something like this, which is a clear boon to all of them, that they don't have to think about, all those formattings. So I have created a small team which only works on the automation. We identify problems, we list them, and we start tackling them one by one. And then we create how to use videos of them and circulate on the floor, so that everybody can understand. And if not understood in one time, they can watch the video over and over again, so that they are sure that how to use that tool. So we have tried to create this in a more holistic way.
I think deep insight.
Yes, and it takes a lot of time to build the tools, for sure.
Yeah.
It looks very novel and fancy on the screen, but yes, I mean, there's a lot of pain that goes.
Heart pain has gone inside
Yes,
before
yes,
presenting.
certainly. Yes, sir. So I think, sir, I think we have some questions from the audience.
Actually, they have not typed in the that Q&A, but
Okay.
some people have raised their hand. Raju, but
Yes, sir, I'm aligned. Mr. Shahjad Irani.
Hi,
Okay.
so an excellent, extraordinary presentation. I am
Thank
from
you.
Ahmedabad.
Thank you.
I have been a professor for the past 17 years at SEPT, and
Okay.
I have taught Grasshopper, Rhino, computational design, digital fabrication to students at SEPT. So a lot of the tools were very logical to me that we have been using, because I'm majorly engaged in the field of tensile structures and tensile architecture. So
Okay,
we have been
lovely.
using Rhino since Rhino 3. So
So that's I mean, you were
it's
the
been
expert of it then.
yeah, it's been a long time.
Yeah.
And similarly, now we have done this kind of programming and tooling for a lot of companies in terms of parametric design, because there are very few people who are engaged in civil engineering or structural design in our field who are dealing with parametric architecture.
Okay, right.
So first, there are 3 or 4 questions that I have. First of all, the thing is that one threshold that we have is that most of the structural engineers and the proofing engineers will ask for a STAAD file instead of an FEM or a FEA output from even something like SAP 2000 or IdeaStructE or something of that sort. So how do you deal with those kind of problems? Because it's very difficult to model those things in STAAD.
So I think you have to repeat the question once again. You said FEA.
So usually when we are talking about connection joints, as you showed for welding
Yeah.
or bolting and everything, now those kind of joinery to model in STAAD and to give them a STAAD output would be quite laborious and
No, I don't think it's even a good idea to do that. I would
yeah.
suggest rather go with your computer with the IdeaStructE and show them what they want for checking.
Exactly. So, but then usually the IIT and proofing engineers, because what
Yes.
our structures or commercial structures, if we are doing stadiums and whatnots, they usually will want an IIT or a government engineer to
Agreed.
approve that. And that
Agreed.
person will usually not approve these kind of softwares because he doesn't know anything about that software.
I agree with you. I think that problem always remains because you have got a variety of people sticking to variety of ideas. So I think, I mean, we have been fortunate with Mizoram that, we had someone from Rambol UK to check those things. So I think he was more open to the ideas. But you're absolutely right. Sometimes the restriction comes from the approving authority and becomes hard. So, even with Sophistic, we feel the same way because
Exactly.
we are creating some very simple example. If I tell you that post-tension eye girders, when you do post-tensioning and you do the long-term losses and redistribution of stresses, something happens which is not so easy to simulate in Excel because, redistribution of stresses due to creep, shrinkage, and losses is something which is a fairly complicated phenomena that happens. But when you have someone from who says, no, I want this to be proved in Excel, it becomes very hard to prove the same thing that comes in sophistic in Excel, because it's something which requires a very high amount of calculations, a large amount of data for different finite elements, which is not possible in Excel. But I
And
agree with
it's
you.
not only not possible, but what I have found that it oversimplifies the problem again.
Yes, that's true.
Which is exactly what you don't want to do. The whole reason of using such tools. So that is one thing
Yes.
which I struggle with.
Yes.
Second question is that when we are coding, now
Yeah.
it's always a trade-off between the amount of time required for coding
Mhm.
versus the problem you're trying to solve. So
Okay.
if, for example, if it is a simple drawing, which probably you are not going to use again,
Mhm.
to code that will require probably 10x of the time.
Agreed.
Right. But then at the
Agreed.
same time, the kind of girders and culverts that you're talking about, you can then extrapolate that to, probably 100 different problems that you'll be facing in your life. So how
Right.
do you decide the threshold that when is it when you would start or instruct your team to start coding certain things?
So, like a very good question. So, like the structures or the problems that we have coded are actually the ones which come to us multiple times. Like if you see the eye girder problem is very clear. They're the most frequent bridges in the world, I would say, not just in India. Like you have eye girders almost everywhere, so we decided to do that. Culverts again is also a very straightforward problem. Natural raft cooling tower, for that matter, is also very a problem that we faced multiple of times. Nowadays they are not making so many, but I could see that there is a pattern in it and it is worth coding. So I think to answer your question, I feel that when I can clearly see that the repetitions are going to be there, and even with the repetitions, I think we always try to limit the number of parameters in such a way that it should not become a burden to code, that you want to code everything. Rather, only pick those variables which are definitely bound to change, and that's why the coding effort goes slightly. So it's I would say it's an intuitive call, but like retaining walls, underpasses, U-walls, culverts, eye girders, all of this simply just made sense. Single cell box girders, it always makes sense that yes, we should just simply code it so that you can use it in future.
Yeah, I just want to add something here.
Yes, sir.
It
Yes.
is always we have to look into the uh, optimization as per for the time, for the accuracy, what we are bargaining. See, even if it is a suppose if there are say 50 eye girder spans are there which we are planning, then I think investing a time in that with a proper accuracy, the even changing in the time and all those things is worth spending and worth doing such kind of program. So it is not very easy to answer that okay it is only one structure, so whether we should put it automation and on not. But suppose someone feels that okay, no, this structure is going to come frequently and that worth spending time technically as well as making a program is a worth investment.
I think your
Time
optimization point also makes it very valid, because we are not designing only once.
Correct.
We are actually designing it repeated over and over to get to the most optimized, maybe processing profile or
Very
bar diameters. I think so. That's why you need something which allows you to go to and fro very fast.
Yeah.
So you're right. Optimization also adds to this.
Like a
tool.
simple cable stay structure, if suppose it is a balance or whether it is a to avoid the river, if we
Yes,
can
sir.
make it little unsymmetric, how much advantage, disadvantages, we can learn very fast with the if we have a this tools are available to us.
Right. Yes.
Very true.
Absolutely.
So my third and fourth question are related. So I'll just try to sum it up very quickly. Now, firstly, are there any scaling up places in India for civil engineers or engineers in the structural design field where they can learn these kind of tools and how to integrate the tools, be it in coding and Grasshopper or something? Or would you or your company be able to put together a program which people could attend? And how do you go about setting an automation team in your company? I mean, where, at what point, and how do you sustain them? That is a combined question.
Okay, interesting. So I think answering point wise, I feel like your first question was, is there a place where people can go and get exposed to these tools? I think there's not, I feel, because I think I also feel that I would want my, the fresh graduates to be exposed to this software so that they have a basic, understanding, or just an exposure would work, because if I have a problem, I would give it to them, they would start working on it. So I also feel that there is a lack of a one single point, maybe, where you get exposed to Midas or Sophistic and Tekla and all of these modern techs. But in our case, I think it was mostly that we were getting exposed from different points, and wherever we saw value, we tried to incorporate that in our system. So like Grasshopper is a very new addition to our working, because earlier we were not using. It's only a couple of years ago that we started implementing through this. And your subsequent question was related to how, setting up an automation team was also something, because I came across someone who was doing this CAD automation for a long time. So I was quite surprised to see that, okay, there's a person who has dedicated his or her career to simply programming in AutoCAD LT. So I thought, so I would say that this was something that I wanted her to be a part of the organization to, solve my problems. And then eventually when we had her, so we started adding a couple of more people who would, start like look for these problems. So we are working jointly, as I told you, that we keep collecting the problems, and we keep asking our engineers, like, what would you want to be automated next? And we keep improvising on our existing systems also. Like, so you saw the color design system, so we added a layer of that DOS system, which is able to do that thing again and again and again for 50 type designs, and then produce the drawings, merge two three softwares together. So I think we are just continuously finding problems to solve. So I think we are able to sustain through that. I mean, it's always it's an agenda to find work and then keep on improvising on the existing system, or keep finding new problems.
I will just add it here, something.
Yes, sir.
I think, though in an industry right now or in an institution, or the colleges are not teaching, but most of the now post-graduation course, generally we keep a internship, and then this internship is generally it is done in a practicing engineers or practicing company. And there certainly, if not, those people learn that what is the practice for the tools, practical tools are available so that he can acquaint. I think IAStructE also is thinking of kind of certification to be given to the such postgraduate engineers, if they do a kind of such courses, so that suppose if suppose he, after the finishing his post graduation, if he goes to completion, after that he goes to the industry, he can have such kind of certification and experiences there. So see, of
Yeah.
course, industry don't, college institutions don't have that facility, but maybe with the internship they can learn with a different private companies. This kind of work.
So I think right now what I can see is that even the software companies are getting very active to teach the students, because they also want the younger ones to pick it up, because then it makes like a clear choice for the organization also to go into that. So as I can see that Sophistic is also doing a lot of workshops, Midas is doing. So I think to answer Mr. Irani, I think you are a professor, so maybe you can ask these people to conduct workshops and they actually conduct. I have recently been a part of it. That they used around 40 workstations. They installed Sophistic on it, and there was a full 2-day training course, I remember, where they gave them the exposure to start from making a simple beam to analyzing, applying loads, and then going into pre-stressing, and everything was told in a very simple way, but an exposure was created. So I think you can contact these softwares to carry out those workshops in your college also.
And IAStructE is contemplating many such courses along
Yes,
with
yes. I think,
this
and that's a
one.
great idea, because then the entire nation is able to access those
Yeah.
information. Yes, sir.
Thank you so much. Thank you so much.
Thank you.
Thank
Thank
you.
you.
Thank you. Thank you.
Yes, sir.
Great, Prateek. And
Thank you, sir.
hey, somebody wants to, one Mr. Iyer. Would you like to?
No, sir,
Is
he
there-
has left. I think he has left. But Miss Niharika Sharma asked one question. She
Okay.
asked, I am using Rhino 3D and SAP 2000 for tall building design
Yeah.
and
Mhm.
analysis for irregular grids. Is there any tool through which I can validate my result using tools you suggested?
Okay, yeah, I can read the query by Niharika. So I think Niharika, maybe I am not sure, because SAP 2000 I'm not very familiar with. Rhino also to a basic level. But if you can elaborate your problem a bit more. So what I can see is I'm using Rhino 3D and SAP 2000 for tall building design and analysis of irregular grids. So you mean to say that they're not orthogonal, just like a regular building line? Is there any tool through which I can validate my results using tools you suggested? Is there any tool? Yeah. So Niharika, can you speak? Yeah.
Yeah, I think she's
Yes. She's there. Yeah.
Yeah.
Am I audible?
Yes, you are.
Sir, actually the building is irregular grid which is of Voronoi shape. And every time I'm getting the feedback from my external panel that I have to validate my results. So it is proper design and analysis the way we are doing in STAAD.Pro.
Okay.
But I'm not able to validate my results because it is an irregular grid which has not been used previously. I'm comparing that particular grid with diagrid and conventional grid, but I'm not able to validate those results. So can I do that in Excel or the tools that you have suggested? All the values that I'm getting of joint displacement, base reactions and everything, can I validate those results with a normal existing building that I have the data?
Okay, I think I'm still not very clear of the problem that you have. So maybe we might have to dissect it a bit more. So is it related to that you're doing it in a software like SAP 2000, but somebody is questioning the results of SAP 2000 and needs to be validated by another software? Is it the question?
Yes, yeah, actually, sir, yes, they are asking the validation part with respect to software because it is a tool and they wanted me to do it experimentally. But the models that I have, it is of 600 meter tall, 500 meter tall. So that thing, I cannot do it experimentally. If I'm doing the scaling part, that is possible, but I have 114 models.
Okay.
So that is not possible for me to do it experimentally.
No, Niharika.
So
this is the
validation is the problem for me.
idea here is, see, generally validation of a software, you can't validate the actual problem or validate the results. So whatever the elements you are using, say for example, you are using a beam element or maybe a 3D solid or a shell element, whatever elements you are using, you can take a textbook problem where the closed form solution or analytical solutions are available. You model that particular problem using those your software. There are a patch test for conversions, etc. So with that textbook problem, you can validate the particular element in that particular
Okay.
software. So once that particular element and software is validated, whatever you are analyzing or the structure by modeling using those elements, we believe that it should give the correct results.
It deems
It is not
satisfied.
possible to validate the results of the actual building. Impossible.
Right, sir.
Yeah.
Thank you, sir.
So thank you everybody. And again, congratulations Prateek for your extremely
Thank you, sir.
Good presentation.
Thank you, sir.
We hope you keep on coming on this platform to show your whatever the new tricks.
Yes, sir. Certainly, sir. If I keep building, I will keep sharing for sure.
Thank you, Pratik, and thank you, Umesh, I think, for your moderation
Yes,
for
sir.
this presentation.
Okay. Thank you.
Thank you. Thank you so much, sir.
Thank you,
In
sir.
case, sir, I just wanted to add this, that in case if somebody has more detailed queries and want to speak to me, I would like to share my email address. Maybe, I mean, if you suggest
So
to be
I think Pratik, they can send it to IAStructE.
and through
IAStructE can
IAStructE.
forward to apna,
Sure.
see, Vikas, you just
Yes, sir. Yes, sir.
Sure.
I think we are requesting there. If suppose someone also has any query or any clarification or anything is there, they can inform to IAStructE, and through Vikas, I think it can come to you.
Absolutely fine, sir. Okay. I think, yes, that will be fine. Thank you, sir.
So thank you. Thank you everyone.
Thank you. Thank you. Thank you,
Thank you.
everyone.
Thank you.
Thank you.